The construction methodology and excavation options for a diaphragm wall are explained in the following sequences. A shallow guide wall is constructed first along the alignment of the proposed wall. The guide wall serves to locate the excavation equipment within acceptable tolerances before the retaining wall construction commences. The guide wall is made from reinforced concrete, typically 1 to 1.5 meters deep. Walls are constructed to tight verticality tolerance. Excavation of the diaphragm wall is carried out in panels. A typical panel is excavated in 3 bites: a left bite, a right bite, and lastly, removal of the middle dumpling. Bite widths depend on the grab type being used, but 2 to 2.8 meters wide is typical. At the same time as the soil is removed from the panel, bentonite mud is pumped into the excavation to support the surrounding soil, preventing collapse into the excavated trench. Excavation continues until the bite reaches the designed depth. Bentonite mud, or in appropriate circumstances polymer, is batched in an on-site plant, allowed to hydrate to gain full gelling properties, and is then used for temporary excavation support. Typically, bentonite powder in bulk or bagged form is added to water and rapidly mixed in a colloidal mixer to produce the desired concentration of bentonite mud. The mud is usually pumped to a storage tank where it hydrates for up to 12 hours. The bentonite particles swell and absorb the water before it's used to support the excavation. When required, the hydrated mud or recycled mud, or a mix of the two, is pumped to the excavation trench to replace the excavated soil, maintaining a constant head of the mud above the prevailing groundwater levels. Excavation of the panel continues, generally completing left and right bites before removing the center bite. Then the center bite is excavated down to the required panel toe level. Steel or precast concrete stop ends are placed at the edges of the excavated panel. The stop end may contain a rubber water bar that later becomes embedded into the concrete. The water bar minimizes water ingress between panel joints once the earth is excavated inside the diaphragm wall. A prefabricated reinforcement cage is then lowered into the excavation between the stop ends. Blockouts for floor slab connections, ground anchors, or other penetrations can be formed in the reinforcement cage. Concrete is poured into the excavation using the Tremie method. This is achieved by use of a hopper and steel tube, extending to the base of the excavation. Typically, 2 hoppers are used for a 6-meter wide panel. The hoppers and tubes are charged with concrete. Then the tubes are lifted off the bottom of the excavation so that the concrete flows out, displacing the lighter bentonite mud upwards. The bentonite is pumped back to the recycling plant as it's displaced. As the concrete level rises in the panel, the Tremie tube lengths are shortened to ensure that fresh concrete is always closest to the concrete-bentonite interface. When the concrete rises to the required level, the Tremie pipes are removed and the concrete is allowed to set. The first panel constructed in a run of wall is called the primary panel. During concreting, the excavation grab and base crane is moved to another location, a safe distance from the concreted panel, and excavation recommenced on another primary panel. The next excavated panel is completed and concreted in the same procedure as just described. Subsequent panels excavated adjacent to a completed panel are called secondary or running panels. The final panel concreted in a run of wall is termed the closing panel, as this panel closes up the length of wall. The stop end is removed from one panel during excavation of the adjacent panel. Diaphragm wall panels can be excavated using several types of equipment, including hydraulic cutters. These are powerful machines capable of excavating into hard rock, but require large bentonite plants and large cranes to hold the cutter. Steering mechanisms are built into the grab body to provide a high degree of verticality control. The hydraulic grab. This type of grab has hydraulically operated closing jaws, and so is able to exert considerable closing force to excavate dense sands, stiff clay, or weak rock material. These grab bodies can also include steering mechanisms. The cable grab. This grab uses only pulley forces to close the grab jaws, and so is more suited to softer ground. and the Kelly grab. This grab type is rigidly suspended from the base machine, whereas the three previous types are rope suspended. The Kelly grab can provide reasonable excavation force and verticality control, but may not be as fast as suspended grab excavation. Typical diaphragm wall widths are 600 mm, 800 mm, 1200 mm and 1500 mm, though other sizes can be used for special requirements. Piling contractors. Think safe, work safe, home safe.